Study Section 6, Allocation and Matching Problems. Introduction. In Study Sections 5, you consider the principle of inclusion and exclusion, PIE. In these study sessions, we shall utilize the PIE in considering problems relating to allocation and matching of objects or persons. The probability aspects of these issues shall also be considered. Learning outcomes for Study Section 6. At the end of these study sessions, you should be able to explain the concept of derangement, solve allocation and matching problems. Derangement. Consider the following example as an illustration. Example 1. At a party, 10 gentlemen check their hearts. In how many ways can their hearts be returned so that no gentleman gets the heart with which he arrived? This problem consists of an n-element set X in which each element has a specified location. We are asked to find the number of permutations of the set X in which no element is in its specified location. Here, the set X is the set of 10 hearts, and the specified location of a heart is the head of the gentleman to which it belongs. Let us take X to be the set 1, 2 to 10, in which the location of each of the integers is that specified by its position in the sequence 1, 2 to 10. Definition 1. A derangement of 1 to n is a permutation I1, I2, In of 1 to n, such that I1 is not equal to 1, I2 is not equal to 2, In is not equal to n. Thus, a derangement of 1 to n is a permutation I1, I2, In of 1 to n, in which no integer is in its natural position. I1 is not equal to 1, I2 is not equal to 2, In is not equal to n. Denote by Dn the number of derangement of 1 to n. Theorem. For n greater than or equal to 1, Dn is equal to n factorial into bracket 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus minus 1 raised to power n 1 over n factorial. Proof. Let S be the set of all n factorial permutations of 1 to n. For j is equal to 1 to n, let Pj be the property that in a permutation, j is in its natural position. Thus, the permutation I1, I2, In of 1 to n has property Pj provided Ij is equal to j. A permutation of 1 to n is a derangement if and only if it has none of the properties P1, P2, Pn. Let Aj denote the set of permutations of 1 to n with property Pj, j is equal to 1 to n. The derangements of 1 to n are those permutations in A1 complement intersection A2 complement intersection An complement. Thus, Dn is equal to absolute A1 complement intersection A2 complement intersection An complement. The pi is used to evaluate Dn as follows. The permutation in A1 are of the form 1, I2 to In, where I2 to In is a permutation of 2n. Thus, absolute A1 is equal to n minus 1 factorial. And more generally, for Aj absolute is equal to n minus 1 factorial for j is equal to 1 to n. The permutations in A1 intersection A2 are of the form 1, 2, I3 to In, where I3, In is a permutation of 3 n. Thus, absolute A1 intersection A2 is equal to n minus 2 factorial. Generally, absolute A1 intersection AJ is equal to n minus 2 factorial for any two combinations ij of 1 to n. For any integer k with 1 less than or equal to k less than or equal to n, the permutations in A1 intersection A2 intersection AK are of the form 1, 2, k, ik plus 1, in, where ik plus 1, in is a permutation of k plus 1, n. Thus, A1 intersection A2 intersection AK absolute is equal to n minus k factorial. Generally, AI1 intersection AI2 intersection AIK absolute is equal to n minus k factorial for any k combination I1, I2, Ik of 1 to n. Since there are n combination k combinations of 1 to n, applying the inclusion-exclusion principle, we obtain dn is equal to n factorial minus n combination 1, n minus 1 factorial, plus n combination 2, n minus 2 factorial, minus n combination 3, n minus 3 factorial, plus minus 1 raised to power n, n combination n minus n factorial is equal to, thus from example 1 above, d10 is equal to, you should be able to supply the final answer for d10. Note, 1. The series expansion for e raised to power minus 1 is equal to 2. dn over n factorial is the ratio of the number of derangement of 1 to n to the total number of permutations of 1 to n. Thus, dn over n factorial is the probability that it is a derangement if we select a permutation of 1 to n at random. The matching problem. Suppose that an absent-minded secretary prepares n letters and envelopes to send to n different people. If the letters were randomly stuffed into the envelopes, a match occurs if a letter is inserted in the proper envelope. Example 2. Suppose that each of n men in a room throws his shirt into the center of the room. The shirts are first mixed up, and then each man randomly selects a shirt. What is the probability that none of the men select his own shirt? What is the probability that at least one of the men selects his own shirt? What is the probability that exactly k of the men select their own shirt? Solution. From our discussion on derangement, the probability that none of the men selects his own shirt is dn over n factorial is equal to the probability that at least one of the men selects his own shirt is 1 minus probability of none selects his own shirt is equal to the probability that exactly k of the men select their own shirt is as follows. First, fix attention on a particular set of k men. The number of ways in which this and only these k men can select their own shirt is equal to the number of ways in which the other n k men can select among their shirts in such a way that none of them selects his own shirt. The probability that none of the n minus k men selecting among their shirts select his own shirt is, it follows that the number of ways in which the set of men selecting their own shirts corresponds to the set of k men under consideration is. Also, as there are n combination k possible selections of a group of k men, it follows that there are ways in which exactly k of the men select their own shirts. The probability required is thus, this result is approximately e raised to power minus 1 over k factorial for large n k is equal to 0, 1, and so on. Summary of study section 6. In these study sessions, you have 1. Learned about the problems involving allocation and matching of objects, persons, from various perspectives, including inability to match, exactly one match, etc. Also, take 2. 2. Also, the arrangement of 1, 2, n as a permutation I1, I2, In of 1 to n such that I1 is not equal to 1, I2 is not equal to 2, In is not equal to n, that is, no object is in its natural position, no match. 3. You also consider cases of exactly one object matches, exactly k object matches, etc. 4. And the probabilities for cases considered were also calculated. This is the end of study section 6. Thanks for listening.